All right, today we're going to dive into one of the most transformative ideas in modern computing, AWS Lambda. It's all about this concept called serverless, and the promise is huge, letting you run your applications without ever having to think about a server again. I mean, just think about that for a second. What if you could focus only on the code that makes your application special, without any of the headache of the hardware it runs on? It might sound a little like magic, but this is the technology that has completely changed how modern applications get built. But to really get why this is such a big deal, we first need to understand the problem it solves. For decades, the foundation of pretty much any application was the server. And yeah, servers are powerful, but man, they come with a mountain of hidden, time-consuming work. Think about it like this. Running a traditional server is kinda like owning a restaurant. You have to build the place, hire the staff, pay for the electricity, and keep the lights on 24/7. And you're paying for all of that even when no customers show up. All that hidden work costs a ton of time and money, whether you're serving anyone or not. And that hidden work? It means you're not just running an app. You're basically a full-time system administrator. You're constantly patching operating systems, trying to guess how much capacity you'll need 6 months from now, struggling to set up automatic scaling, and configuring complex logging. It's a whole separate job, and honestly, it has nothing to do with the cool thing you're actually trying to build. So what's the alternative to running your own empty restaurant? Well, what if you could just hire a world-class catering company that only shows up when you have an event, does its job perfectly, and then poof, they're gone? That, in a nutshell, is AWS Lambda. So what is Lambda officially? It's a compute service that runs your code, period. You never provision or manage a server. It scales like crazy, automatically, from just one request to thousands per second. And here's the kicker. You only pay for the exact time your code is running. No more paying for idle machines. This quote from AWS just hits the nail on the head. It gets right to the heart of it. AWS handles all of that messy, hidden work, the maintenance, the scaling, the security patches. Your only job, provide the code that delivers value to your users. It is a massive shift in focus. And don't think for a second this is some niche tool. Lambda is an absolute workhorse. You see it powering everything from automatically resizing a photo the moment it's uploaded, to running the entire backend for a massively popular web or mobile app, or even processing real-time data from thousands of smart devices. Okay, so it sounds amazing, right? But how does this serverless magic actually happen under the hood? Let's pull back the curtain and look at the surprisingly simple, event-driven model that makes it all possible. It really just boils down to this simple 4-step flow. First, you write your code in what's called a function. Second, you give that function permission to access any other resources it might need. Third, and this is the key, you connect it to an event trigger. Think of it like a doorbell. And finally, when that event happens, when that doorbell rings, bam, Lambda automatically runs your code. Now that word event can sound a bit abstract, but it's really simple. It's just a little package of data, usually a text file in a format called JSON that contains information about what just occurred. For an image upload, the event might have the file name. For a web request, it might have the user's details. It's the what that triggers your function's how. To really get a handle on Lambda's performance and, more importantly, its cost benefits, we need to understand the lifecycle of the environment where your function runs. It's a 3-part story. So, every Lambda execution environment goes through 3 phases. First up is the init phase, where Lambda prepares the environment, loading up your code and any dependencies. Then you have the invoke phase. This is where your function actually runs and processes the event. And finally, after a period of inactivity, there's shutdown, when the environment is cleaned up. And this brings us to a super important concept, cold starts versus warm starts. A cold start happens when a new request comes in, and Lambda has to do that full init phase from scratch. It takes a little extra time. But, and here's the cool part, if another request comes in shortly after, Lambda reuses that already warmed up environment. That's a warm start, and it's much, much faster. And here's where it all connects back to your wallet. You only pay for the time your code is running in the invoke phase, and it's measured right down to the millisecond. You don't pay for the init time, you don't pay for the shutdown time, and you absolutely do not pay for the time that environment is just sitting there idle, waiting for the next request. So how do we architect our applications to take full advantage of this model? It's really important to understand a few key patterns for success, and a very common trap to avoid. So here's a classic mistake.
Function A gets called, and then it calls function B and just waits for it to finish. The problem? You're paying for both functions, but function A is just sitting idle, literally burning money while it waits. This is inefficient, and it tightly couples your services together.
Now here's the better way. Instead of calling function B directly, function A drops a message into a digital waiting line, or a queue. It finishes its job in milliseconds. Then, sometime later, function B picks up that message and does its work independently. The functions are decoupled, which is cheaper, more resilient, and it scales way better. And this simple example points to a few core design principles. You want to build your functions to be stateless, so they don't rely on memory from previous runs. You want to minimize coupling between functions by using services like queues. And you should architect for real-time event-driven processing, not old-school batch jobs. So what's the big takeaway from all of this? What does this whole shift towards serverless computing really mean for how we build things in the future? At the end of the day, it's this. Serverless fundamentally changes the game by letting developers offload all that undifferentiated heavy lifting of managing infrastructure. It lets them pour all of their energy and creativity directly into writing the code that solves a problem, builds a product, and delivers actual value. And that leaves us with one final question to think about. With all the time, money, and mental energy you'd save from not managing servers, what new ideas could you bring to life? The possibilities are pretty exciting to consider. Thanks for joining me on this explainer.